Okay, good evening. And we'll get this going. Okay, as Simon says, this is World Earth Day, which I think is absolutely appropriate. I'll be talking about the oceans tonight, but really all life on Earth depends upon life in the oceans, so absolutely critical for our ecosystem. So I'll be talking about the GOES project or the GOES Foundation, and I'll give you a wee bit of background first of all before we get going. I sail with Diane, my wife, and supporter, and she's been instrumental in making sure everything actually works and doing a lot of the research as well. And in the photograph of Diane on the bottom left, you see in the background the Rio Formosa in the Algarve off Faro. And it's one of the most important marine reserves for seagrass in Europe and also for seahorses. And my picture's on the right-hand side with our yacht Copypod in the background. And it's a Harbour Grassy 43, which we're having great fun with. So a wee bit of background about GOES. It's part of a social enterprise called Clean Water Wave. We set up Clean Water Wave about 4 years ago out of the research I was doing in my former company, Dryden Aqua, where we developed water treatment systems that could turn water such as the River Ganga or contaminated water into drinking water. So we set up Clean Water Wave as a 100% asset lock social enterprise to deliver clean drinking water for particularly low income countries and island communities. And one of the things that we hope to do in our travels in Copypod is be of not only environmental support to many of the island communities that we hope to visit, but also help them with their water supplies, so drinking water as well as their wastewater, to try and eliminate or reduce the level of pollution that has been caused not only by the locals, but by tourists, especially with regards to the coral reefs, which are critically important ecosystems for the marine environment. And in my career, I've been involved with all forms of water and wastewater treatment. The photograph you see now is from effluent from a textile plant, and textiles cause about 10% of the world's wastewater and also burn about 10% of the world's energy in terms of fossil fuels. So I've worked in textiles in China and India and also in Bangladesh. I spent 5 years working in Dhaka in Bangladesh, studying the effluent treatment plants and looking at the environment. And in Bangladesh or in Dhaka, they managed to destroy 100% of their water supplies. It's a city of 22 million people, and 100% of all the surface water is destroyed, and 90% or more of their groundwater has been destroyed by the textile industry. And the Chinese are currently building a pipeline from the north of Bangladesh into Dhaka to deliver drinking water, which I find shocking that they've allowed their environment to get into that condition. So one of the projects we're involved with was trying to develop a new form of effluent treatment for the textile industry. And I spent 5 years working in Dhaka, not full time, it was really over a period of 5 years. And we eventually managed to build one of the biggest effluent treatment systems for textiles. And it's a relatively simple system that the Bangladesh can actually operate. And it's zero impact. It does not cause pollution to the receiving environment. So we've open sourced that technology. And if it's adopted, then we have the potential to eliminate up to 10% of the world's wastewater. So that's an ongoing project and still progressing. But as a marine biologist, my passion is working with the aquarium industry. And we've been fortunate enough to be involved with over 100 of the world's largest public aquaria. This one's in Dubai, where they use our filtration systems. I designed the life support systems for the Istanbul aquarium. And getting closer to home, we also provided filtration systems for the Lisbon aquarium. So, these are massive installations. A typical ocean tank will have 4,500 cubic meters of water with hundreds of different species of fish and invertebrates. So we absolutely know what keeps these animals alive. And you might be surprised to know that none of these big aquaria actually use seawater. It's all artificial seawater. They might be built, on the coast and can have access to seawater, but none of them will use it because it's too toxic. They're too scared to use natural seawater because it can contain, priority chemicals or heavy metals or high levels of organic matter or hydrocarbons, which would cause the aquarium a big problem. So in most of these big aquaria, it's actually artificial seawater, and they operate as 100% closed systems and recycle all the water. One aquarium I was working on was the Epcot in Walt Disney in Florida, and they've had the same water in the aquarium for nearly 30 years. Just recycle the same water. As long as you can look after it, then it's absolutely okay to do that. You may also be surprised to know that if you put a 1 meter section of PVC pipe into these huge systems, you probably end up killing all the animals in the aquarium, because certain materials such as PVC plastic is really horribly toxic to most marine life, especially the juvenile stages. So it's working with the aquarium industry has been a great learning curve. It's also a good example of what can happen to the wider ocean ecosystems. So things that can happen inside an aquarium could potentially happen in the oceans. So it raised my awareness over the toxicity of certain chemicals and how delicate life actually is, below the waves in our oceans. So I really want to cover quite a few topics tonight, and really to reinforce that all life on Earth actually depends upon the oceans, and it really depends upon the planktonic life forms in the ocean. Now, plankton from the Greek means ocean drifter. And most of the plankton is actually almost microscopic, below 1 millimeter. But siphonophores are also part of the plankton, and they are the biggest, or at least the longest animal on the planet. They can actually grow to over 100 meters in length. So plankton covers a whole range of different organisms. The main issue is that they drift, or they don't really have a strong means of swimming great distances. Now, second point is that plants and animals, in the oceans, they are responsible for controlling our climate. It's where most of our carbon dioxide is sequestered, and the oceans historically have produced 99% of all our oxygen. So they are critically important for the environment and for climate change. And unbelievably, the UN didn't really consider the oceans all that important in terms of climate change until about 2015. That's when the focus started coming on to the oceans with regards to that. Also, the third point is that we have been using the oceans as a dumping ground for the last 100 years. The mantra of the industry and the water industry was that the solution to pollution is dilution. If you dilute it enough, then it cannot possibly be dangerous or toxic to the environment. But not all chemicals are the same. Some chemicals don't like going into solution. These are called hydrophobic chemicals. It's like oil. You put oil into water and it floats on the surface. If you give it a good mix, then it will form an emulsion, small droplets. So these chemicals don't go into solution, and they can be absorbed onto particles and concentrated by those particles. And then the particles are eaten by the zooplankton. And that's how, a chemical, even though it's a very low concentration or addition to the marine environment, it can still be extremely toxic. And the marine environment and the animals that live in the plankton are absolutely amazing. Here we have a photograph of a phytoplankton. It's a plant called acantharian, and it's a metal life form. It's made from strontium, or has strontium as its skeletal form. And strontium actually is it's an element, and it was first discovered in Scotland. And there's actually a village named after this metal called strontium. We then move up the plankton chain a wee bit to diatoms. Diatoms are really important in the marine web. They are perhaps responsible for about 20 or 30% of all our oxygen. And these organisms are made from silica. And when the diatoms die, they form a rock or a mineral called flint. So, flint was critical for early humans for making fire. So if it wasn't for diatoms, then human evolution and development could have been dramatically different. Moving on to another really important plant called a coccolithophore. Again, it's made from carbonate in this occasion. And again, critically important for the marine ecosystem and for our environment. And when these organisms die, they form limestone. So an example would be the White Cliffs of Dover. They are plankton, essentially coccolithophores, and they only measure between 5 and 100 microns. 100 microns is about 1/10 of a millimeter. So coccolithophores are just about visible if you look very closely at the water. Moving into the animal kingdom, one of the most important organisms or groups are called copepods. Now, I won't say too much about copepods now. I'll come back on to them. But it's also the name of our boat. And because of the importance of copepods and because nobody had ever called their yacht copepod before, we grabbed that name, and it's now part of the logo for the GOES project. So copepods, are really important. And one of the things that we did last year was we sailed from Scotland, from the Clyde, down to Portugal. We're accompanied by another yacht, Sue and Reg, on board Misty Blue. So the both of us set off last July, I think it was. We managed to get away, I think, the day that COVID restrictions lifted, and escaped the UK. So a short video of our trip. But an interesting passage. Mostly it was good weather, but going through the Bay of Biscay and round Finisterre, we got into some fairly serious weather, with winds up to about 40, 45 knots. And even containers on board container ships were falling off. So we were not only dodging that, the waves, but the containers. These are common dolphins. And unfortunately, more than 10,000 of these lovely animals are killed every year in the Bay of Biscay by the fishing industry. And as we approached into Bayona, we were able then to take a plankton sample. And here you see a trawl being made behind the boat. So we're collecting samples of zooplankton and then having a look at it under the microscope. And one of the things that we're picking up huge amounts of was plastic, microfibers of plastic. You can see some blue fibers in the bottom left-hand corner. And also you see here copepods darting around the screen. But it was the amount of plastic which was actually fairly shocking. We were finding big lumps of microfibers. Now, one of the things that we're keen in doing with the GOES project is collecting plankton samples and measuring the amount of plastic that we're finding in the water. But using conventional plankton trawls, we found was not really practical on board a yacht. First of all, you had to slow everything down to about 1 knot in order to throw out the net. And also that if you wish to really count the number of animals and plants and particles of plastic, then controlling a plankton net and the amount of water you're filtering becomes almost impossible. So we developed a new type of filter to be used on board the yachts. You can see it in the front of the screen here. It's effectively a pipe. And this pipe contains about half a litre of water, or exactly half a litre of water. And we put a filter paper. You can see it down the bottom right-hand side. The filter paper goes inside the pipe, and then we suspend this filter vertically, or hang it so it stays vertical, and then pour half a litre of water into the filter. It takes about an hour to filter that sample, but we then collect everything in that water down to 1 micron, in fact 0.45 microns. On board the CopyPod, we have a small microscope. It's a USB microscope. And we then have a look at the filter paper under the microscope. And we count the number of plankton that we're finding, the zooplankton, the size of the zooplankton, the number of plants that are called phytoplankton. It's really easy to see the microfibers. They're easy to identify. And then you have bits of plastic, which are actually very difficult to identify. But the plastic fibers are very easy to find. Now you can see on the monitor here that there's an image of a small CopyPod. That's actually my business card. The business card is under the microscope. And you cannot see the CopyPod on the business card, but we're magnifying it about 50 times here. So it gives you an idea of the scale of what we're looking at. We only need to magnify the sample by about 30 to 50 times to get a good view of the copypods and phytoplankton. So we're really starting this collaborative data collection project, and hopefully many of you would like to join us in doing this. The reason why we're doing it is that many oceanographic ships don't actually go out into the oceans and collect plankton and filter samples below 100 microns. Usually when they're doing plankton trawls, it's up to about 240 microns for the plankton samples. Sometimes they might go down to about 60 microns, but the area where we're looking at is from 20 microns up to about 1,000 microns. So there's a huge hole in the literature on the plankton levels and microplastics in that range. So moving on to the copypods, I said that these are really important organisms. And to put them into perspective, in every liter of water in the ocean, you will find around 10 of these organisms in every liter. Collectively, they have a biomass or a mass of 5 gigatons. That's 5 billion tons of these crustacea. They measure about 1 millimeter in size, and there are 5 billion tons of these organisms living in the ocean. Now, I appreciate that's a really difficult number to get your head around, but to put it into perspective, it's equivalent to 17 million 747 jumbo jets. And if you put them all nose to tail, they'll go around the planet 30 times. And these organisms, they migrate from 400 meters below the surface to the surface every night. So it's the biggest mass migration of animals on the planet. And when they swim up to the surface, they move more water than the moon and the tides. So it's a massive amount of water movement, energy transfer, and this has not been factored into the climate change model. And these copypods, they actually consume almost their own body mass every day. And that's equivalent to 30 times the amount of carbon produced from the burning of fossil fuels. And when they defecate, about 6% of their poop actually gets into the abyss. And that locks out about 25% of all the carbon produced from burning fossil fuels, which is about 3 gigatons. It's 3 billion tons that this organism is responsible for sequestering. And I bet very few of you actually have even heard of copypods, but it's the most important animal on the planet in terms of climate change. Now, the plants are also really important, and this one is called Prochlorococcus. And it's actually a bacterium that contains chlorophyll, called a cyanobacteria, but it's still a plant and a really important plant. And it measures only 0.6 microns in size. So that's 2,000 times smaller than a millimeter. But there are more cells of this bacterium than there are grains of sand on the planet. And collectively, it produces more organic matter than 7 times all of human agriculture. And it produces 20%, up to 20% of all our oxygen. And unbelievably, we didn't even know it existed until 1985, because most of the oceanographic ships, are using plankton nets at 60 microns or greater than that. So it was simply missed. So it demonstrates how little we actually know about what is going on in the marine ecosystem below the waves. A recent paper which was published has also confirmed that Prochlorococcus is very sensitive to microplastic pollution. So we'll come back to that later. The diatoms are also a really important group of phytoplankton, and they are responsible for fixing an order of 45 gigatons of carbon every year. Most of that carbon is recycled back into the as food for copepods and other organisms, but diatoms collectively probably produce in the region of about 30% of our oxygen. Now, getting a wee bit more technical and into the climate change model. The reason why we have climate change is from the burning of fossil fuels by man, it exceeds the ability of nature to use that carbon. Now, from the burning of fossil fuels, we're kicking out nearly 10 billion tons every year. And amazingly, almost 2 billion tons for the burning of trees, which I find absolutely shocking. And on the plus side, we have the ocean sequestering, copepod sequestering carbon, about 2.5 to 3 gigatons. Then you have soil, bacteria and fungi in the soil, absorbing a lot of the carbon, and also minerals in the form of silicate absorbing carbon. You'll note that terrestrial plants are only about 0.6 gigatons. So terrestrial plants actually aren't that important in terms of absorbing CO2. And if we take, for example, the Amazon rainforest, which has often been referred to as the lungs of the planet, in reality, it doesn't produce any oxygen. In fact, it probably kicks out about 1 gigaton of CO2 into the atmosphere. And that the reality of the situation is that the marshlands and peat bogs of Scotland are actually more important in terms of climate change than the Amazon rainforest with regards to carbon. Now, I'm not advocating that the Amazon rainforests aren't important. They're critically important ecosystems for different reasons, but from the point of view of carbon sequestration, no, they're actually net producers of carbon into the atmosphere. Now, whenever you kick carbon into the atmosphere, some of it will dissolve into the water. CO2 is highly soluble in the water. And when you dissolve it, it forms another chemical called carbonic acid. It's a bit like fizzy water. Fizzy water is acidic, or Coca-Cola, which is carbonated, is also quite acidic. And if you poured Coca-Cola onto brass, then it will help to clean up the brass. It's because it's eating into the metal oxide layer. And this is called ocean acidification. It's sometimes referred to as the evil twin of climate change. Climate change is bad, but in reality, ocean acidification is actually catastrophic. Yet it's hardly been acknowledged as critically important. Most of our focus has been on carbon sequestration, and ocean acidification has been largely ignored. Now, I won't go into too much detail with these graphs. They're from the IPCC, the Intergovernmental Panel on Climate Change, and it's from historical data going back over 100 years. But what it is that going back to about the 1940s, 1950s, oceanic pH, which is a measure of how acid or alkaline the water is, the oceanic pH was about 8.2 or thereabouts off the north coast of Hawaii. And over the last 70 years, the pH has dropped from 8.2 down to 8.04, 8.05. And if we then extrapolate that data forward 25 or 30 years, it's going to hit 7.95 by about 2050. That is, if we continue as called business as usual. It means that no change in the burning of fossil fuels. And from the perspective of doing the life support systems for many of the world's big aquaria and also large aquaculture systems, I've got a great deal of experience and knowledge of what happens to ecosystems when you approach a pH of 7.95. One great example was about 20 years ago. I was involved with the sea bass industry in Greece. And the sea bass industry was about to collapse because they couldn't get the juveniles beyond about 1 gram in size. And what it was that the pH of the water in the Eastern Mediterranean was about pH 8, which rendered the sea bass juveniles sensitive to a viral infection. It wasn't the pH that was impacting on the fish, it was their increased susceptibility to viral infection, which was killing them. And as soon as we realized that, then we could put in remedial action to stop it from happening by just simply raising the pH slightly. So, the impact of pH on marine life is very subtle, but also extremely profound. And even if the world went carbon neutral by the end of this decade, then it won't make any difference. The pH of the oceans will still drop to 7.95, might be delayed by about 5 years, but it will get to the same endpoint. And I fear that when it gets to that endpoint of 7.95, then most of the life forms in our oceans will not survive, because 50% of them are based on a mineral called aragonite. Now, aragonite is a form of calcium carbonate, and at a pH of 8.04, it actually starts to dissolve in the water. And it reminds me of a study. One of the first oceanographic ships was the Challenger, which was out of Edinburgh University in 1870. And they surveyed the Eastern Pacific, and they discovered what's called the Challenger Deep for obvious reasons. It's the Mariana Trench. It's the deepest part of the oceans. It goes down to 11,000 kilometers. And in Edinburgh, in the museum, they brought back some coccolithophores, which are carbonate-based plankton, from that survey in 1870. And 2 years ago, they sent out a second ship, same location, same time, to collect coccolithophores. And they found that these carbonate-based plankton were half the size. So it just demonstrates that the carbonate is starting to dissolve in these organisms. And given the importance of them, it's kind of critical. So aragonite, it's is the mineral that coccolithophores are made from, and other organisms such as foraminifera, which are also really important. But your bivalves, your mussels, your oysters, the sea starfish, echinoderms, there are many organisms that live in our oceans that are based on carbonate. And if you start taking out 10, 15, up to maybe 50% of all life in the oceans, then there is going to be consequences of that. And potentially there could be what's called a trophic cascade collapse. If you take out one part of the ecosystem, then like a set of dominoes, you can start knocking over other parts of that system. So potentially we could lose all the whales, seals, birds, and most of the fish, as well as the food supply for 2 billion people within the next 30 years. So you can see that ocean acidification is more than an evil twin. I classify it as the evil big brother of climate change, and the world has almost ignored it. But it won't once it starts biting. Now, to continue to depress you all, the next point are the oxygen levels. that oxygen is produced by plants and it's consumed by the decomposition of organic matter and by the burning of fossil fuels. So we know how much oxygen is in the atmosphere and the impact of burning fossil fuels. And it appears that the oxygen levels are actually dropping 4 times quicker than the CO2 is going up. So this is not climate change. This is loss of plants. It's ecosystem destruction. Now, you don't need to panic because there's enough oxygen to keep the world going for several hundred years, but it's an example that we're actually losing major parts of our ecosystem. And we now know that we have lost more than 50% of all life in the ocean since the 1950s. And currently, according to satellite imagery from NASA and other reports, one of the first was published in Nature from Dalhousie University. It has been quite a contentious report, but collectively, it does appear that 35 to 50% of all marine life has been lost since the 1950s. Not from the Industrial Revolution, but what we're now calling the Chemical Revolution. And it's continuing at a rate of 1% year on year. So you can really work out the maths on that one, what's going to happen. So life on Earth absolutely depends upon what happens below the waves. Really important. So the big question then is, why have we lost more than 50% of all life in the ocean since the 1950s? And we know it's not climate change because if you have slightly elevated temperatures, if you have more carbon dioxide coupled with nutrients, it's plant food. There should not be a decline in the plants living in the oceans. There will be a change in distribution, as the temperature changes or the currents change, but there is a massive decline in productivity. And our explanation is pollution. So the solution to pollution is not diluting the chemicals because they are building up in the environment. And since the 1940s and 50s, we've been dumping into the oceans chemicals like DDT. And unbelievably, the Americans dumped in 500,000 barrels of DDT sludge off the coast of California over the last 40 years. And they're surprised that 350 kilometers of kelp fields have now gone. That was blamed on climate change, but I'm sure that the DDT had probably some stressing aspect on the kelp, which rendered it more susceptible to climate change. So it's chemicals like DDT, PCBs, fire retardants, PBDE, PFOS. I would recommend that you watch a film called Dark Waters. It's about this organic fluoride chemical. Fairly horrific what it's doing to the environment, and you're probably familiar with it in the form of Teflon. It's your non-stick plastic. It's actually one of the most persistent toxic chemicals on the planet, and we cook with it and use cooking utensils with it. So I'd recommend that you do not use Teflon pots and pans. Plastic, has been in the press a great deal over the last 10 years. And plastic is really dangerous to the environment. But it's not just the plastic you can see, it's the plastic that you don't see, which is probably even more dangerous. And a recent survey by a UK oceanographic boat measured up to 21 million tons of microplastics in the Atlantic Ocean. That's microplastics between 35 and 300 microns in size. It was an estimate, but the estimate range was from, I think, about 10 to 21 million tons. So by any standard, that's a huge amount of plastic. And it equates with up to 7 particles of plastic in every litre from the surface down to a depth of 200 meters. And I find that absolutely shocking that we've allowed the environment to get to that state. Now, getting back to the chemical pollution, again, it's difficult to really appreciate and understand how some chemicals can be horribly toxic to the marine environment. And by way of example, I'll use coral reefs. You may or may not be aware that we've actually lost more than 50% of the world's coral reefs. And 25% of all marine life depends upon coral reefs as a nursery ground. Now, corals are an interesting organism. They're an animal, but they live with a symbiotic plant called a dinoflagellate, and it lives inside the coral and it gives the coral its color. And this plant is really important as an energy source for the coral. Now, there's a chemical called oxybenzone, which is the active ingredient in many sunblocks. And when you go in swimming, some of this chemical can wash off. It's oil-based, so it floats on the surface of the water. And next time you're on a beach or go swimming or watching people going swimming, you can quite often see an oil slick coming from them. That's the chemicals coming off their skin, which will contain oxybenzone. Now, it floats on the surface because it doesn't want to be in the water. It's called hydrophobic. It's got a phobia against being in water. And it also tends to be absorbed by particles which have a similar property. And many of the microplastic particles have the same hydrophobicity. So the plastic actually acts like a sponge. It sucks these chemicals out of the water and it concentrates them many thousands of times. And then what happens is that the plankton then consumes that particle of plastic containing all the chemicals. Now, oxybenzone itself is relatively non-toxic, but the way a sunblock works is it's meant to stop UV radiation from damaging your skin, but it doesn't actually block the sun. What it does is it changes the wavelength from a short wavelength to a long wavelength. I won't bore you with the chemical details there, but in the process of doing that, it releases a free radical, which is very toxic to the coral. The coral senses this, it dumps its algae, it's called coral bleaching, and now the coral becomes very sensitive to elevated temperatures and climate change. So what you have here is a stressor in the form of the oxybenzone, and it's rendered that coral susceptible to climate change. If it wasn't for that stressor, then most of them would survive. Now, remarkably, there's about 30,000 tons of this chemical produced for the cosmetic industry. And if you do the maths on this, at 62 parts per trillion, all you'd require is about 70,000 tons to wipe out most life in the oceans. But the world manufactures nearly 2 million tons of this chemical every year, because 1.5% of plastic will also contain oxybenzone as a UV stabilizer. It's also in 3,500 other cosmetics and cleaning products. So I'd really recommend that you read the label and check what you're buying, because chemicals and products that are toxic to nature are probably also toxic to you. Now, we've produced a short film, which I hope will run properly on the network. So if it doesn't, then we'll just skip it, but I'll give it a go. Okay, just to recap on that, we manufacture, or the world manufactures 2 million tons of this chemical every year, and 70,000 tons could wipe out most marine life. And to depress you even further, oxybenzone is one of perhaps 10,000 similar toxic chemicals. So we really do have to get a handle on what we're using and discharging into the marine ecosystem. And what we can all do something as well. And one of them is to buy coral safe, ocean safe cosmetics and sunblock. And this is a list of 4 which have been certified to be safe for coral reefs. So I can give, well, they're all listed on our Goals Foundation website. So if you can't take a note of them now, then you can go onto our website and download that information later. Now, with that amount of plastic we have in the oceans, it means that almost 1 in 15 of every living organism, animal and plant, almost down to the size of bacteria, contain plastic in some form. And because that plastic has absorbed and concentrated chemicals, then this is an explanation, or a possible explanation, why the plankton are dying at a rate of 1% year on year. And it also gives us hope, because with an understanding of what is happening to our oceans, it gives us a mechanism to reverse it, to change it. Now, we already know that we're too late to save the oceans by reducing carbon emissions, because we are going to hit a pH of 7.95, maybe even 7.9. So knowing that chemical pollution and plastic pollution may be the reason for the loss of marine life and the reduction of the pH, we have scope then to reverse that by regenerating the plankton. We can't do it by reducing CO2 emissions, but if we stop plastic pollution and toxic forever priority chemical pollution, then there is scope to actually recover life in the oceans and to bring it back to a condition that we had in the 1950s. And the reason why we can do that is that it takes around 60 years for plant biomass to double, or to, trees, for example, can take hundreds of years to grow. So collectively, it takes 60 years for the plant biomass on land to recycle. It just takes 3 days for ocean biomass to double. The reason for that is that most of the ocean life, or 60% of all ocean life, is actually less than a millimeter in size. And many of the bacteria, like Prochlorococcus, that produces 20% of our oxygen, can probably double every 60 minutes. So if we take the constraints of the marine ecosystem, if we can minimize or prevent plastic pollution getting into the environment, then there is huge scope to recover the system. And it could happen really very quickly. So we'll go back to the graphic earlier. The reason why we have climate change is because we have 5.2 gigatons of carbon going into the atmosphere. If we can take the brakes off the marine ecosystem and restore it to the condition that we had in the 1950s, where we had double the productivity, then we can potentially increase the sequestration of carbon from 2.5 or 3 gigatons up to 6 gigatons. And if at the same time we reduce the burning of fossil fuels by 15%, then we actually bring the world into neutrality in terms of CO2 levels going into the atmosphere. We achieve zero or balance. And that is even without reducing or only reducing carbon emissions by 15%. It's by the elimination of toxic chemicals going into the environment, going into the air and the water and the soil. So nature really has the potential to be our best ally in the fight against climate change and restoring nature or regenerating nature. But we really have to take the brakes off the ecosystem now and do that within the next 10 years, because there's also huge inertia in the marine ecosystem due to the volume of the water. But I think if we can achieve that task within the next 10 years, then we can actually reverse the pH, dramatically increase the productivity of the oceans, increase the CO2 sequestration, but at least we stop the oceans from exhibiting a total collapse due to the dissolution of aragonite calcium carbonate in the water. And it may not be that difficult to do this as well. You know, one of the main aspects is that we have to stop pollution from municipal and industrial wastewater. And really only about 10% of the wastewater treatment plants in Europe and North America are fitted with tertiary treatment systems to remove microplastics and toxic chemicals. And even then, they don't really do it all that well, but they can be modified to completely eliminate or almost completely eliminate microplastics. We know this is possible because we've done it. You know, it can be done. But about 80% of the world has no effluent treatment whatsoever. You know, one of the places where I was working was in Bangalore in India. It's a city of about 10 million people. They have no effluent treatment, and all the wastewater ends up in big lakes in the middle of the city. And you can imagine it's a horrible mess. And all that organic matter ferments, it produces methane. And the lakes are often catching fire. You know, if you Google burning lakes of Bangalore, then you'll see the state of it. And that is the same situation with many of the cities. They simply do not have the effluent treatment. And it's a major source of methane. And methane is 15 times more greenhouse gas than carbon dioxide. So it's something that we have to address. But we can all have a role to play in fighting climate change and regenerating nature. And one of the simplest ways of doing that is to buy organic products. You know, if you're fortunate enough to be able to afford to do that, then it means that herbicides and pesticides and insecticides like neonicotinoid are not being used. And again, you know, we're now at a situation, if we take the almond trees in America as a case and example, that because of the reduction of we've lost 80% or more of all flying insects and pollinators. And it's now got to the state with the almond trees in California that they used to import beehives to pollinate the plants, but now they're having to use drones to drop the pollen. And you know, it's ridiculous to be in that situation. And equally, the land insects are dying off at a rate of 1% year on year. So we really have to stop using herbicides and pesticides, especially chemicals like neonicotinoid, which is actually an addictive pesticide. The insects actually seek it out on purpose because of the addiction they can get for it. Difficult one for sailors is not to wear plastic clothes, especially a fleece, because wearing a fleece with microfibers, you know, every time you wear it and wash it, you actually release billions of particles of plastic into the wastewater. So we're working with a team at the moment on filters for washing machines, so that we can at least capture maybe 70 to 90% of the plastic microfibers before they get into the wastewater network. Toxic cosmetics, you know, I couldn't believe when I started working with oxybenzone how horribly toxic this chemical was to marine plankton. So read the label, use the ocean safe, coral safe sunblocks. And also check any other cosmetics that are being used that they don't contain chemicals such as oxybenzone. Become carbon neutral or reduce the burning of fossil fuels. It's important, but in the whole scheme of things, it's not that important. You know, we have to do it, but way too much emphasis has been put on the reduction of fossil fuels and building windmills and electric cars. You know, what we should really be doing is looking after nature, trying to recover and restore nature, not only on land, but in the soil. The soil biome for the bacteria and fungi, really important. And the use of all these chemicals in agriculture is really destroying the biome that lives underground. Again, it's an ecosystem that's largely unseen, but critically important. We can plant trees, as long as we don't burn them down, then it's always good to do that. But in terms of importance, it's the wetlands, marshlands, peat bogs, mangrove swamps. These are the places where most of the carbon on land is sequestered. And by way of example, mangrove swamps only cover about 0.6% of the terrestrial ecosystem or the land mass, but they absorb 30% of our carbon. So really important to look after these environments. Atmospheric pollution is also really important, and we're lobbying, again, the industry about tires. Now, you wouldn't immediately think of car tires as being of all that importance, but 200,000 tons of dust from car tires goes into the atmosphere every year. And it gets picked up by the Earth's magnetic field and gets drawn down at the poles. And the consequence of that, along with carbon from diesel emissions, is that the snow and ice is changing color. It's much darker in color. And in some places in the Arctic, it's almost black. And if you change the snow and ice from being a reflective white color to a darker color, then it'll absorb more energy and it'll melt. So the changing the color of the snow and ice is equally responsible for melting of the Arctic, as is climate change. Also, a recent report has shown that there's up to 10,000 particles of plastic in every kilogram of ice in the Arctic. So it ends up being one of the most toxic environments because of its location with the Earth's magnetic field drawing very fine particles down. Now, the car tire plastic is horribly toxic. So, you know, we've been lobbying the tire manufacturers not to use certain chemicals or products. And is it possible to make a tire that doesn't form this dust? So that's a really important issue. But, you know, the two big ones are effluent treatment. We have to treat all our wastewater to a standard that is equivalent to drinking water. We have to be either zero discharge or zero impact. We can no longer be discharging plastic into the environment or toxic forever chemicals or pharmaceuticals, which are also extremely damaging to marine life. And we have to, again, also lobby government and industry to develop green chemistry. You know, we're not against plastic or the use of chemicals. They're very important. But there are many different alternatives to the sunblocks, which we're currently using, which are horribly toxic. There are safe alternatives. So with just a change in behavior and, you know, applying green chemistry, then I'm sure that we can solve these problems. And if we do that, and if we can achieve that within the next 10 years, then I'm very hopeful for the marine ecosystem and environment. We will still have climate change to a degree, but at least we won't have a catastrophic loss of the marine environment, which would be a great deal more damaging to society than climate change. And I've actually written a paper, which is now published in the Ocean Science e-journal, which you can download a copy of. It's a bit of a heavy read, but it brings everything together in the one document. And I think that's really all I have to say for now. But I apologize for it being a wee bit doom and gloom, but it's actually a good news story. because it gives us a way forward, and that way forward is to eliminate pollution and to bring back nature. And we've actually also been putting some numbers onto this. What would it cost to do it? And with regards to eliminating aquatic pollution from wastewater treatment plants and really solving maybe 50% of the green chemistry issues, it would be a lower cost than COVID. So it's doable and it's not that expensive. Okay, thank you.
Gosh, thank you very, very much indeed, Howard. That was an extraordinary talk. Do you mind unsharing so that the rest of the folk can see you properly? We've got a number of questions. I see there's one from Nick, who should already be able to open his own microphone. Nick, do you want to come in? Nick Owens?
Yeah, sorry, Simon. Yes. Yeah, well, I have a number of questions actually, Howard. That was a tour de force. The particular question I've got was that last data slide that you had of identifying the sort of the percentages of things that we can do to end up to to come up with 100% of solving climate change. I just wondered where did those numbers come from? Are they your views, or are they, are there some data from somewhere else? Because that's obviously an incredibly powerful message that is, it goes to the heart of the COP26 that's coming up. Today's announcements from the UN climate change announcements and so on. So I'm just interested where those numbers came from.
Oh, you're absolutely right. It really turns the climate change on its head, completely, because the focus has been purely, or to a very large extent, on CO2 mitigation. But
sure,
if you look at the data from the IPCC and the impact that we're having on ocean acidification, I'm not sure if you're a marine biologist or not, but you'll appreciate.
I am. Yes, I am a marine biologist.
That you'll know the impact that pH will have on ocean ecosystems and how delicate they are to a pH shift. Now, one of the arguments has been that often it's referred to, well, in the past there was much higher levels of CO2 and lower pH in the oceans, and everything was okay. Such as during the late Cretaceous period, about 67 million years ago. But when you look at ocean chemistry from that era, the calcium levels were 5 times higher and the magnesium levels were about 2 or 3 times lower. So the Langelier index of the water gave a different saturation index for calcium carbonate, which allowed the pH to drop to 7.5 without the dissolution of aragonite. But now we've got a much lower level of calcium in the water, much higher level of magnesium. And again, from a document published by the IPCC, they stated that aragonite starts to dissolve at pH 8.04. And by the time we get to 7.9, it's effectively complete. Now, by any measurement, if you take out about 50% of all marine life, then, in your own opinion, that's going to have a major impact on all trophic layers, and nobody can really predict, exactly what will happen as a consequence of that. But whatever it is, it's not good. So the table at the end of the report is not any published information. It's really just based on my own experience and knowledge. So it's not something that you can look up. It's there to initiate debate and discussion and argument. So,
okay, all right, okay, thank you. I would like to have a debate with you about some of your pH points later. It's not appropriate for now, but that's we can have a discussion about that at some future point, perhaps. Thank you.
Great, you're welcome.
Thanks, Nick. We'll go first to James Anderson, who's got his electronic hand up, and then we'll go to Joseph Taggarty. So, James, come in, please.
Good evening. I am not a microbiologist or a marine biologist. I'm just a sailor, but I have been to various places in the Pacific, for instance, like Saguaro, where you can't go unless you've got your own boat. And one of the things that I was surprised and shocked by was the amount of plastics you find on the high tide line wherever you go in the world. But am I right in thinking that perhaps the main message of what you've been saying is that we ought to shift our focus from climate change into getting rid of microplastics, because actually it's the microplastics that perhaps is causing climate change? Is that the right?
Yeah, to some degree you're right. No, we have to continue, to try and mitigate and reduce the burning of fossil fuels. That is always important. But by simply eliminating or going net zero with regards to carbon, then we will still hit a very low pH, which will be catastrophic to the marine environment. Now, one of the reasons why the pH is dropping is certainly because of the dissolution of carbon dioxide into the water, but also if you have a reduction of plants, then there's less carbon dioxide or carbonic acid being removed from the water. So I think climate change to an extent is being caused by anthropogenic pollution, reducing plant life in the oceans, which is then allowing ocean acidification and reducing the ability of the oceans to sequester carbon dioxide. So you're right, it's not so much climate change impacting on the oceans, it's the oceans impacting and causing climate change, which is a 180-degree shift on what we're currently doing. And plastic is really important in that regard. You can't have 21 million tons of microplastics in the Atlantic, almost the same number of particles as you have zooplankton animals, without that having an impact. And we know that plastic is in itself toxic, to the plankton. And plastic is everywhere. That a friend of ours, Tim Schmidt from the Eden Project, he's the ambassador for the Seychelles, and they sent 25 students to an island called Aldabra, which is a protected island. And I think 25 students spent 5 weeks there, and they collected 50,000 flip-flops off the beach and about 25 tons of plastic. So, plastic itself, plastic you can see is dangerous to a lot of marine life, especially the turtles. But plastic is also, it breaks down to smaller particles. It's also great for growing certain types of bacteria, and one in particular is called Vibrio, which is a pathogen for fish and coral. So if you have a flip-flop or a piece of plastic or a polythene bag simply rolling over a coral reef, then everywhere where that plastic bag touches, the chances are it will transmit or transfer Vibrio bacteria and kill that coral. So all you have to do is touch it and you'll kill it. All the plastic has to do is touch an animal or touch the coral or touch the plankton, and it could well kill that animal. So plastic is really, really dangerous.
So that's a very easy target for us non-scientists to focus on. Is we need to get rid of plastics, and particularly microplastics.
Absolutely. Well, the thing is, getting rid of microplastics is easier said than done. And it's normally certainly we have to filter wastewater to remove the microfibers and the microplastics. And also, atmospheric pollution, again, is very difficult. There was a study done in the Pyrenees, 100 kilometers away from the nearest city, and they were measuring 500 particles of microplastics dropping out of the atmosphere on every square meter every day. So, the problem we've got is massive in that respect. But once there's an awareness about it, then we can then start to do something about it.
Thank you very much. I thought that was a brilliant talk. Thank you.
Thanks.
Thank you very much, James. Joseph Taggarty, and then Carol Robinson. So Joseph first, please.
Hi there. Can you hear me?
Loud and clear. Go ahead.
Okay, great. I just wanted to ask about the reference for the quantities of DDT dumping in California. My boat's on the west coast of Scotland, but I winter in California every year, so I was interested in that.
There is quite a few reports on it now. It's been studied by the Scripps Institute out of San Diego. And I think also in the on our GOES Foundation website was a reference to it as well. So it was 500,000 barrels of DDT sludge that were disposed of off the coast. I'm not quite sure how far off the coast. I think it was about maybe 30 or 40 kilometers. And the barrels are leaking, and the steel's breaking down and releasing the DDT into the water.
Okay, thank you.
Thank you, Joseph. Carol Robinson. Carol, if you unmute your microphone. Yes, go ahead, please.
Perfect.
And then we'll go to Spike and Anne-Marie after that. Sorry. Carol, go ahead.
Thank you. Thank you very much. I was particularly interested in the information you gave about sunscreens, because I understood that coral bleaching was mostly caused by temperature increase. So I just wondered if you could point me to the research that's shown that sunscreens are as important as temperature increases in coral bleaching. Thanks.
Yeah, absolutely. Well, we're working with a Dr. Craig Down of Heraticus Laboratory in Virginia. Craig is from Hawaii, and he's actually a forensic chemist or a litigation chemist, and he's been involved with oxybenzone for, I think, the last 10 years. So Craig Downs is responsible for most of the reports and papers on oxybenzone. And I can certainly send you some peer-reviewed reports on that, but if you simply do a Google search, then you'll find hundreds of papers, if not thousands of papers, on the toxic effect of oxybenzone, not only on the coral, but on a whole range of other animals and also on humans. It's responsible for causing a condition in babies called Hirschsprung disease. So it's what I was saying, that chemicals which are dangerous to the environment can also be dangerous to people. Now, the work of Craig has shown that this chemical is toxic to the planula of coral. The planula is the planktonic stage of coral, which then settles and turns into a coral. And they've confirmed that it's toxic at 62 part per trillion. What that really means is if you take a 5 milliliter teaspoonful of it and add it to 100 Olympic-sized swimming pools, that will give you the same concentration. So it's an unbelievably small amount of a chemical can have a big impact. But the recent work from Craig, which is unpublished at the moment, is showing that it's toxic down to 10 part per trillion. So there is really no safe concentration of this chemical. And given that there are very good and safe alternatives to it, then we absolutely should not be using this product in cosmetics.
Thank you. I'm just surprised at the data that shows that after a temperature or an El Nino different temperature rise, that's when you get all the coral bleaching.
All right, sorry, I didn't really answer the question here. But what you'll find is that nothing is ever simple. You know, as I said, that the oxybenzone impacts on the coral, it can result in the coral discharging its symbiotic partner, or it will stress the coral. And when animals are under stress or organisms are under stress, then they become more susceptible to elevated temperature. Now, coral, if it's fit and healthy, will normally survive temperatures up to 32 degrees centigrade. Indeed, some of them will go up to 34 or even 35 degrees C, as we've seen in the Red Sea, if they are fit and healthy. But if they are stressed by something else, or if their symbiotic partner is stressed, then a temperature of 29 to 30 degrees centigrade will damage or kill the coral or render it susceptible to infection and disease. So it's all about stress that the animal is under and trying to reduce that as much as possible. Okay.
Thank you.
Thank you, Carol. I'm trying to keep track of who's coming in next. So Spike and Anne-Marie first, then Paul Burden, and then Dan Duncan. Spike, go ahead, please.
Yeah, I hope that you can hear me.
Yes, loud and clear.
Excellent, thank you. Howard, I am super impressed with your presentation. Impressed and depressed, especially when you're talking about the fact that you have, or that we have a 10-year window to basically turn the situation from where it is today into a more stable one. And I shared in the chat, I shared a link to the ocean cleanup program that is now not only focusing on the oceans, or plastic in the oceans, but also in the rivers, because 80% of all the plastic that ends up in the ocean seems to come from 1,000 rivers, and they want to do that in 5 years. I think that is hugely ambitious, but we will need to do that because 10 years it sounds like a long time, but it's not. I lived 10 years in Southeast Asia, in the Philippines and Indonesia, and looking at the pollution, the plastic pollution in those areas, it is just incredible. So there is so much to be done, and 10 years, I'm not as optimistic as you are probably with the 10-year time window.
Yeah, we may not achieve it within 10 years, but at least if we're, well down the road to achieving that target, then it can only help the environment and the marine ecosystem. I may not be entirely correct with what I've been saying. I was really doing it also to try and stimulate argument and debate, because we have to do this. But I don't think anyone could complain about cleaning up the environment and trying to restore nature. I remember, when I was, very young, driving in Scotland at night with my parents, it would have to stop the car maybe about 5 times to rub off all the moss that were on the headlights and the windscreen. Now we're driving and you don't have to do that. The insects have disappeared on land as well. And the same thing is happening in the oceans. Again, when I was fishing off Oban, when I was 10 years old, every time you go off the end of a pier, you'll catch a fish. Now you don't. The fish are going, and it's happening all over the world.
Do you want to come back on that, Spike, or?
No, that's fine. I mean, there is, I was just trying to make a comment on the 10 years. I understand that it is to basically get the debate on really started. I think it's very impressive the way you're putting it forward and you're presenting the argument. And we need to, get a lot more publicity around this, this entire topic. But well done. Thank you so much. You've really woken me up for sure.
Actually, on the question of plastic, we're working with a company from Bangkok. And there's a big plastic problem also in Thailand and Malaysia, that they have developed technology to turn plastic into diesel, into oil. And they're actually making it profitable. So, the problem with plastic pollution and recycling is that nobody has been able to make it economic to do it. But now it appears that technology is coming out that can actually do that. So as opposed to it being dumped into rivers, if it becomes a viable asset that people can make money from, then that I think is the way of actually tackling this problem, or one of the ways.
And that process is not releasing CO2?
Well, eventually it will do, but much better. What happens is that you effectively heat the plastic up to about 700 degrees centigrade, and you turn it into a gas, and then you turn it from a gas back into a liquid again. Now that process itself is self-powered by the waste that you're treating, so it will release CO2, but I'd rather release some CO2 rather than release that plastic back into the environment.
Clear. Thank you so much, Howard.
Thank you, Spike. So next is Paul Burden, followed by Diane Duncan. Paul, go ahead, please.
Good evening. Thanks very much for the excellent talk. Really appreciate it, or feeling slightly worried. One thing that you were talking about Teflon as being a substantial pollutant, and my understanding is that Gore-Tex is expanded PTFE, which is another name for Teflon. So should we be concerned and trying to find different foul weather gear? Because I guess we're all wearing Gore-Tex in our foul weather gear and boots and things.
Yep, absolutely. You know, PFOS and PTFE, or the fluorocarbons, these chemicals do not break down in the environment, and they, you know, it's now reckoned that 99% of every human on the planet contains PFOS, you know, in your body at some point. And we know it's dangerous. So we really should be looking towards developing alternative materials as opposed to relying upon these toxic forever plastics. You know, I'd recommend that you watch that film, The Dark Waters. It's not a great film, but it gives you a bit of an idea of what is actually going on, and it's not acceptable.
Have you found an alternative to Gore-Tex for your oilskins, or are you stuck with it like us?
I use a lot of merino wool, but preferably.
The base layer is a bit of an easier solution than the outer layer.
But you know, after sailing in Scotland for many years, I'm now moving to warmer climates, so hopefully I won't have to.
Fantastic.
Yeah, thanks very much.
Paul, thank you. Dan's next up, and then we'll go to Richard Kidd. Dan.
Oh, hi. It's actually really follows on from that last comment, is that actually a lot of the sailing manufacturers are looking at materials. And in fact, just earlier today, I was being sent by Google all sorts of things on safer wetsuits and dry suits and sailing gear. So the manufacturers are responding, which is great news. And I think that, you know, we try to track as much of these things as we possibly can. But I think it's worth having a Google at things, because the response is there, and there's a lot of people looking at recycle it, and they are recognizing now that a lot of these chemicals, just that people don't want them, and they know that they're not good for them. So it was really just to comment on that, and to let people know that innovation is happening. And I think the more that we can ask, every time I go into my chemist, I've been asking for them to sell non-toxic cleaning products, and lo and behold, they've done that. Although one of them, when I looked at it a wee bit closer, the small print in sort of type, I think 0.6 said highly toxic to the marine environment, but the chemist has taken it off the shelf. So I guess we need to speak up, and if we as sailors all know that there's a problem, because ultimately, you know, if we're using these products, it goes down our sinks, it goes down our plug holes, and they, you know, most of our wastewater plants were designed 100 years ago. They were never designed for a lot of these chemicals. If we take drugs or pharmaceuticals, 30 to 90% of that gets piddled out of our bodies, and again straight out into the environment, out into our rivers and our coastal waters and our oceans, and that has an impact on all the little animals and baby fish and all that kind of stuff as well. So I think as sailors, I really hope that we can speak up, and that we, if anybody would like to use this presentation or would like help to do a presentation, I'm wondering if Oliver is on the line or on the call tonight, Simon, because I know he wants to be a GOES ambassador down in the Canaries, and really try and raise awareness of this. So if it's something that people want to do, you know, please do get in touch with us. So thank you.
Thank you, Dan.
Hello, can you hear me?
Can we just, I can hear you, Oliver. We'll bring you in a moment. We've got Richard Kidd first. So we'll go to Richard Kidd, and then we'll go to Oliver Henriks. Richard, go ahead.
Oh, hello. Yes, it's Susan, actually.
Sorry.
Just the thing. It's all right. It happens every time. It's just the thing I wanted to chat, that is the paper being presented at the COP26 conference in November?
I'm working on it, but it looks like the conference might actually be delayed. We're not entirely sure yet, but I'm actually delivering one in Edinburgh in the Royal Society just before COP26. So hopefully we'll get a slot in the conference. Also depends where we are. We're trying to actually be someplace warmer at that same time. So we'll see.
And also, are you putting in anything for the funding from the Duke of Cambridge Initiative on Innovation for Climate Change?
No, we're all self-funded funded at the moment, but we are working with a number of organisations that we hope will help support us. You know, one of the things that we're doing is that, you know, we wish to kick off this collaborative data collection project. And part of that is developing an application for mobile phones and computers to allow data entry. The program is currently being written by one of our associates in Zurich, but it will require a bit more work. So we're looking for support to try and develop the applications and the software and the management of it. So we're working on that, but right now we're doing everything ourselves.
Right, thank you.
Thank you, Susan. We'll go next to Oliver Heinrichs in, I'm not sure if you're in the Caribbean or in the Canary Islands at the moment, Oliver, and then we'll follow that with Gary Crothers from Northern Ireland. So Oliver, go ahead, please.
Hello, can you hear me?
Yes, loud and clear, go ahead.
Oh, perfect, yeah. Well, hi Simon, hello Dr. Howard, and yeah, I'm in the Caribbean right now. We'll be back on the Canary Islands soon. And yes, I've been just introduced with Howard a week ago, and we're going to support them, and it's great. It's been quite of a shock actually for us. I mean, we always try to be as clean, as green as possible, also at work, reduce plastic use and all that. But I'm one of those that maybe a lot of us as well thought that oxygen, think about the Amazon forest and all these things and climate change, and a lot of new things came up lately. Maybe you have seen the film as well about Seaspiracy, about the fishing industry, and now knowing about the harm that all those products are doing, all those, let's say, especially the sunscreens and all that. We've done a research about products and to have eco-friendly products to support them, and we have found that they're extremely expensive. That's on one side. And that's the question. On the other side, another question is actually, if this is all so clear, I know that in Hawaii they have banned sunscreen, in Palau as well. All those sunscreen have those chemical products. Why are they not doing this worldwide? Why, if it's so clear that the phytoplankton, well, and the zooplankton, the plankton overall, is so much important and nobody talks about it? And if this is so clear, why are the governments not really doing and pushing something? It's always this question in my mind. Why does the big companies, and it starts maybe with the government giving money to these companies to actually make the products more available to the public? Because when I say to a sailor, don't use all these products, they say, yeah, this costs €5, the other product costs €50. It's also a question about making it available to the public.
Okay, Howard?
Yeah, well, Dan is probably better at answering that question than I am. But with regards to the sunblocks, we've actually just purchased some Badger sunblock. It came in today. And it is comparable cost to the ones containing oxybenzone. So maybe you're looking in the wrong place, Oliver. We're finding now that the coral safe sunblocks are really not that much more expensive, if at all, than the standard ones. On the issue of why has nothing been done about oxybenzone or plastic, the last 5 years the government has been debating what is a plastic microparticle. For goodness sake, it's to spend that length of time trying to define what plastic is, and then they'll probably spend the next 5 years developing the techniques to measure it and to quantify it. It's we went to the UNESCO conference on the oceans. It was in Paris, June, I think, 2 years ago. And there were 3 outcomes from that conference. It was marine biologists. There was 500 marine biologists at the conference. And I remember there were 3 statements at the very end. One was, it was nice to live by the sea. Great, you know, most people like to live by the sea, but an academic conference, that was one of the key points. The second one was that we're doing a really wonderful job at cataloging the destruction of the oceans. So, you know, we're cataloging, we're monitoring, we're quantifying, but not actually doing anything about it. You know, I think we should be taking a precautionary approach. That, you know, if we know plastic is dangerous, if we know a PFOS or a PCB or you know, a chemical is toxic, well, we should be looking at green chemistry or eliminating that product from the environment. I don't know why we do not take a precautionary approach. We have a very close friend, Professor Jacqueline McGlade. She was head of the European Environment Agency for 10 years. And in her report, she said exactly the same thing. You know, we should be taking a precautionary approach to these things. And then, you know, sure, we do all the research, we do all the analysis and quantify it, but much rather quantify how bad something could have been rather than experience how bad it actually is going to be if we don't deal with it. And the third point was that the UN really only woke up to the oceans being important from the point of view of climate change in 2015. And it's scarcely a part even today in the IPCC reports. Yet the oceans are the primary factor dictating and controlling our climate. So I don't understand why that is the situation.
Thank you very much. Thank you very much. And well, that's why you also collaborate with the OCC now and with us. Let's make the sailors do some work while they sail over the oceans. Thank you very much.
Is it just in the too difficult box for governments? How is that the problem, or is it pressure from big business? Because presumably there's a lot of money behind plastics and ultraviolet stabilization, etc.
Well, I'm not entirely, again, Dan's probably better answering that question, but today we actually had a Zoom call this morning with the largest insurance company in the world. And that same question had hit them, you know, because at the end of the day, it all comes down to money and risk. And I think a lot of it is to do with awareness, you know, of what those risks actually are. And, you know, there's a huge amount of really good research going on in many academic institutes, you know, all around the world, but many of them are also focusing on very tight, small areas, not looking at it holistically as a big picture. And, you know, from my own experience, you know, there's perhaps only 10 of us in the world involved with the design of the life support systems for these large public aquaria. Now, you know, if you're working in a laboratory doing ecotoxicological testing, you might only be dealing with 10 fish in a 2-cube tank over 4 months. We are working with hundreds of species of fish and invertebrates in communities over years, and if not decades. So it's a much better proxy of the ocean system rather than an aquarium in a laboratory somewhere. So we are actually much more acutely aware of the issues than many of the government and academic scientists working in this area. So there's a lot to be learned from Aquarists running these systems. Now, balanced off against that, I've also worked all over the world with the aquaculture industry. You know, currently we're working in Vietnam to really put 25% of the shrimp farming industry onto recycle, because they can no longer pump seawater in to look after the shrimps because the seawater has become too toxic. And then I'm working in, you know, toxic, you know, discharges in China and Bangladesh and India. So I've seen it from all different sides and angles, and very few academics or government laboratories have the, you know, the opportunity to see that. So holistically, when we look at it as a whole picture, then maybe we get a better idea of what's going on than many of the other laboratories. So that, I think, is part of it as well. And what we're now trying to do is just raise the awareness, raise the debate, ask the questions, and get people to challenge us. We don't have all the answers. We don't know if we're completely right, but what we do know is that the pH is dropping, and that when the pH gets down to 7.95, certainly 7.9, then marine life in the oceans will be horribly stressed and susceptible to infection, disease, or dissolution. And that's not good for anyone.
I will go next to Gary Crothers, and then I've got a question for you. So Gary, please.
Okay, good evening, Howard. That's a brilliant talk and very sobering, frightening, in fact, and a hell of a lot for likes of myself to take on board. And I have no sort of background in marine biology or anything. Obviously, any of us who spent time at sea are always keen to minimize pollution, but well, I've always had sort of a general sort of a pollution is bad, full stop, but the level of detail that you've gone in and the background that you have with regards to keeping large animals in tanks and stuff, is a brilliant take on it. That example you gave there of was it SeaWorld or whatever, they're using the same water for 30 years is because they can't use using recycled water for the last 30 years because they can't use the water pumped out from the sea is tremendous. I'm actually going to check out on my local, we've some sort of an aquarium down in Portaferry. I'm going to see, do they use pumped in seawater? Anyway, it's a frightening thought, everything you listed, and so much to take on board, and probably more towards Simon. I'm just wondering, would be any chance of publishing those slides separately so as I could go through them slowly? There's just a hell of a lot to take on board. And then my one question then with regards to sailors is there's a lot of times when you're out in isolated places where there's no way of getting plastics, which you cannot get away from. They are everywhere, and they have to be dealt with on board by some mechanism. And currently the two choices are either you burn them on the beach or you put them in landfill. So both bad solutions. To your mind, which would be most preferable?
Well, certainly not burning them, especially the likes of PVC that releases toxic fumes into the atmosphere. One of the other things I've been responsible for is the effluent treatment systems for around 50 landfill sites in the UK. And most of these water treatment systems are designed and built by engineers, and they do a good engineering job. But most of water treatment is biological, and that's the way we've designed these systems. And one of them, I prefer that refuse doesn't end up in a landfill site, but if it's going to go there, then you encapsulate it so that it doesn't leak out the bottom. There's a cap goes over the top, so none of the gas escapes out the top unless it's controlled, and you extract the methane and then you use that as an energy source. And the water coming out can also be treated. Now, one of the first we did was for the city of Colchester. And it was a lagoon-based system. And the last lagoon turned into a nature reserve. And it had a restriction order placed on it because it became a habitat for great crested newts. And we couldn't do any maintenance work on the system. The quality of the water was so high. So when someone tells me they can't treat the water or remove the microplastics, or they can't remove a chemical, from the water, I tell them, no, that's not the case. And here's the technology, which is very simple biological technology to do it. And it's the same that we did in Bangladesh, in Dhaka, for one of the biggest textile companies. We completely eliminated the pollution. and it was a lower cost than what they were currently doing.
Okay, that's great. I love the way your talk scared the living daylights out of me at the beginning, and then there was some hope at the end, and you're continuing on that there is hope that something can be done.
I'm sorry it scared you, but I actually think it's a good news story, because there is no hope in solving climate change by carbon mitigation. You know, because China is going to keep increasing, you know, for the next decade at least, you know, building coal-fired power stations and all the pollution that comes out of that. And the same goes for India and South America. So I don't think there's any hope in being carbon neutral for the next 20 years. And by that time, you know, we'll have caused a huge amount more damage. But this actually gives a mechanism by which, if we can at least, you know, treat our wastewater and cut down on the plastic and improve the quality of the environment and regenerate nature, then, you know, as I said, with just the copepods alone, you know, they or the zooplankton, they drop out about 30% of all our carbon. And if we can double the productivity of the oceans, then maybe we double the amount of carbon we can lock out. So we solve the problem not by trying to reduce CO2 emissions, but by just cleaning up our act, you know, preventing pollution.
Yeah, that's excellent. Those figures. That's why I was asking for the slides to be separately. Those figures are, you know, they're all news to me. You know, like I know nothing about this, and the scale of the problem that we have to deal with is so huge, it is frightening. But it has to be tackled at a global level and at a governmental level and at an individual level, so that individuals like myself can have some sort of background knowledge to lobby local governments whenever they're maybe going to upgrade a local water treatment. We have a water treatment plant not too far from my own house here, and whenever the rains get too high, the damn thing overflows and washes all sorts of rubbish out into the river, and it's not only disgusting, it's huge pollution, just along the lines of what you're talking about. So it's a huge issue.
Yeah, well, there was a documentary on the BBC, Panorama, and they're reporting that there were 400,000 cases of pollution from UK municipal or English municipal wastewater treatment plants last year.
Yeah,
you know, that is really not acceptable by any standards. So it's raw sewage being dumped in. Now, again, another example which is fairly horrible. You may remember the Orca in Scotland, Lulu,
yeah,
which washed up in Tiree, I think about 4 or 5 years ago. The levels of PCBs in our flesh was such that they couldn't breed. So, you know, the Orca in Scotland are at that point now that they are going to go extinct. And then the same will happen, I guess, with all the other cetaceans and maybe the seals as well. So it's real, it's happening. The same thing's happening in the St. Lawrence, that with the beluga, you know, they're disappearing, and they've measured more cancers in the beluga whale than any other animal ever investigated. So, and it's also happening in Antarctica. There's no place that's safe from this. So we have to do it. We have to stop the discharge of toxic forever chemicals into the environment.
Yeah.
Thank you, Gary. Two questions from me, Howard. First one, if we do manage to stem the flow of plastics into the water, what happens to the microfibers that are in the oceans already? Does it eventually sediment out, or is it there for eternity?
Yeah, good question. To be honest, nobody really knows. But again, going back to the Mariana Trench or Challenger Deep, you know, they have been putting grab samples down 11 kilometers and grabbing the sediment there. And they're actually finding that the levels of plastic and PCBs in the Mariana Trench are 50 times higher than the most polluted rivers in China. Okay. So again, that was work from a UK, I think it was Newcastle University. So, the plastic and the waste is ending up in the abyss, where the temperatures are very low. But there is some good news that we believe that certain plastics will be metabolized, albeit very slowly, by fungi and bacteria. PVC is one that may not be metabolized, but it does look like some of them are actually going to be slowly broken back down again. The danger is that as they're being broken down, do they release something else which is toxic, molecular plastic? We don't know is the answer to that, but we think that it will end up in the abyss. It may get locked out of the system eventually in the abyss, and that then allows the upper layers to recover and to regenerate. But we don't know what will happen in the abyss.
Sure. Second question. I guess this is the big one. The OCC's up for doing what it can, and there's a groundswell of support for environmental type projects these days. So we obviously support the challenge grants, etc. What could or should we that lead the OCC actually be doing practically? I'm intrigued by your citizen science project, and making that known to our members, etc., makes sense, and presumably that data all gets fed back into the into the monitoring. But what as an organisation should we be doing? Lobbying, awareness, lists of clothing we should buy that we shouldn't buy, or suntan creams that we should or shouldn't? What would your advice be?
Yeah, well, we're trying to develop the GOES website to give as much information as possible. But I think the key point here, or the several key points, it's really awareness raising and dissemination. We need to get other organizations looking at this or working with us and debating it and taking action. We seem to be really good at recording, monitoring, cataloging, quantifying, but not actually doing anything. And what we want to do is actually, to raise the awareness that these are issues and we can do something right now. And sure, we can do all the monitoring and checking, but let's stop toxic chemicals going into the environment and plastic going into the environment. And here's how we can do that, by using tertiary treatment on the back end of municipal wastewater treatment plants, or by lobbying government and industry not to make car tires with horribly toxic material. And on that front, we're also potentially working with E-Extreme, which is a new, not Formula One, but it's an off-road version of it. And they're an environmental organization. So again, we're raising the issues with them about the pollution caused by tires. And the other thing that's happening is with stormwater, that every time it rains and you have stormwater, then most of the time it just bypasses the effluent treatment plant, or it washes through the effluent treatment plants and discharges everything untreated. We should be having attenuation zones to trap stormwater and not allow it to get into the environment. So there are many things we can do. Some of them will be easy to do, some will be difficult to do. But ultimately, we all depend upon the ocean for our, with regards to our climate and with regards to, food and economy. There are so many things that we depend upon the oceans for, that we have to protect them, and we have to try our best to recover and regenerate the marine life, which we've exploited and destroyed over the last 100 years.
There's a few members that are quite keen on supporting things like these robot plastic connectors that they're putting in the mouths of rivers in some of the Far Eastern hotspots. Is that worth pursuing? That there's kind of project that people can get behind to, does that raise awareness as well, or are we just kind of fooling ourselves with that sort of thing?
Well, I think absolutely everything helps, and if we can capture plastic before it gets into the environment, and that can only be a good thing. One of the biggest sources of plastic are water bottles. Yeah, so it's absolutely huge amount of plastic bottles that are consumed. And by way of example, one of the projects we're working on was in West Bengal, about 200 kilometers north of Kolkata. And we're working on an Indian village, and their average income was about $2 a day, but they were spending about 25 to 50% of their income in buying bottled water. And so that's why we've set up Clean Water Wave, because what we want to try and do as a social enterprise is to deliver sustainable drinking water systems so that people don't have to buy bottled water. And our aim is to try and eliminate or work towards eliminating plastic water, which is ridiculous. And so there's lots of things that are being developed now and coming through. But there's a huge amount more we have to do in raising the awareness and the dangers of plastic. And we're only really touching that subject now.
I see Dan's put some comments on the chat line, but there's a lengthy post from Barbara Cowpey. So Barbara, if you'd like to open your microphone and come in, please.
Can you hear me now?
Yeah, go ahead, please. Go ahead, Barbara.
Oh, wow. All these months and it finally worked. I did work in water and wastewater treatment for several years in water recycling.
But Barbara, just if you could move a little closer to the microphone, you're just a bit distorted.
Okay.
That's better.
Okay. I did work in water and wastewater treatment and water recycling for several years. And it was interesting to me when you made that kind of a side comment that most of these systems are designed by engineers. And most of them are civil engineers, which is very far away from water biology and control systems and all those types of things. So I'm glad that you mentioned that, because it needs to be the science and the systems development really need to broaden their scientific input, for a short way of saying it, as best as I can. But you mentioned that you have many issues in the UK where you have pollution events with different wastewater treatment places. And we have that here in the US as well. But when they report those pollution events, it doesn't report everything. It only reports on those components that are measured and monitored. And I don't believe that microplastics are involved in that.
Yeah,
so
you're absolutely right. They only monitor what is regulated, and microplastics and most of the toxic chemicals are not regulated, so they're not even monitored. And when we were trying to get some of these chemicals analyzed in the UK, then none of the water laboratories could actually even measure them. And when it comes to pharmaceuticals, there are no laboratories that we could find that could actually analyze the water for the chemicals. So we're pretty well stuck.
We're not even finding it until after the damage is done and we're measuring in the ocean. Is that correct?
Yeah, it's well, again, it depends how the chemicals or the products are measured. Now, the most toxic of chemicals are those that are hydrophobic. They don't want to dissolve into the water. And we had one incident with an environmental organization in the UK on this. We inquired as to the levels of PCBs, and they said that they were, effectively zero, in the water in the sea. And it turned out that the samples were being filtered by 0.45 micron paper before they analyzed the water.
Right.
Whereas all the chemicals were actually on the particles they removed with the filter. So, you have to look at things, as a whole sample. And also what we know as a research, it was Maribeth research, it's a consortium funded by the European Commission. And they measured the levels of PCBs on particles in Antarctica. And they found that the concentration in Antarctica was the same concentration on particles in the North Sea.
Wow.
There just happened to be 7 times more particles in the North Sea, so 7 times more PCBs. But what that means is that zooplankton that are eating particles are eating the same levels of PCBs in the North Sea, which is one of the most polluted seas on the planet, and it was the same as Antarctica. There was no difference in terms of that concentration. So that, that is scary, and it's one of the things that we want to try and do, with the OCC and ocean going yachts, is to collect the water samples with the plankton filter, and so we can then start to get a handle on the amount of plastic that's in the water or particles that are in the water, because by measuring the number of particles, we get a measure of the amount of chemicals that may well be in the water. And that's never, I think, really been done before, certainly for particles under 60 microns. And also to get a measure of the animals and the plants. So we can start to, with enough measurements, we can then start to really catalog this and apply a bit of artificial intelligence to analyzing the data to see what patterns that we're going to see, to give us more evidence that we can use to help justify, the claims and statements that we're making, or to support it anyway, to try and get some action. So,
if I may ask, oh, I'm sorry, go ahead.
No, I was finished. I was just saying we need all the help we can get. So any yacht wishing to do sampling, that get in touch, and we'll be very pleased to work with you.
What can we do? Like you mentioned the PCBs, I also spent quite a bit of time in power generation related application, but PCBs have just been being eliminated in my career time.
Yeah, well,
and that's just in the U.S. So where can we pressure, or how could we affect removal of something like that that's an industrial pollutant, moreover than an individual one?
Okay, well, sticking with PCBs, they were actually banned in Europe, I think, in the 1970s, and the same also in North America, because it was deemed to be too toxic a chemical to have in products. But I'm not quite sure of the numbers, but it's somewhere in the region of 100,000 tons of post-consumer electronics are exported from the States every year to countries such as India for recycling. And then you have the small companies with blowtorches taking apart these circuit boards to get the precious metals. And the recycling techniques that are being used are releasing PCBs back into the sea again. So, you're responsible then for exporting that chemical and for it being released at a different point into the oceans. And Europe isn't any better in that. It's only recently that China and Malaysia and Thailand have banned the plastic. The UK was exporting, I think, 90% of all its waste plastic, to Malaysia and Thailand and the Philippines, and they were then just simply dumping it on the ground. That's ridiculous. So we're all responsible for that, and I think if we're aware of what's going on, then we can then maybe start to complain to our MPs and and to get this action stopped.
Thank you very much.
Howard, you're in danger of going on all night here, but I just want to bring in Brian O'Flynn. Brian's has several questions on the Q&A, and his microphone's been open for a while. So one last question from Brian O'Flynn. Please go ahead, Brian.
Howard, congratulations. Very good talk. Excellent, really. Now, two things that occurred to me. One was that cyanobacteria apparently brought about the atmosphere that we have. And the other question I had was, because Bill Gates has proposed dusting the atmosphere to reduce global warming, would it not be more practical, on the basis of what you said, to flood the oceans with crushed limestone or bicarbonate or calcium carbonate rather, to reduce or to rather increase the pH? That's it. Thank you.
Yeah, well, you're absolutely right. Cyanobacteria were one of the first, if not the first type of plant. And, as I said in the presentation, 99% of our oxygen came from the oceans, and it was cyanobacteria in the oceans, and they are still doing it. Prochlorococcus is the most numerous plant on the planet, and it's cyanobacteria. So they're absolutely important, but they're also very, very sensitive to microplastics and other chemicals. Dusting the atmosphere, I'm not quite sure what that refers to, but I have heard of using titanium or some reflective material to try and reflect energy back into space. I don't know if that's what you were referring to, but I think it's nuts to try and do that. There have been some talk about using carbonates or minerals to buffer the pH. If you go back a bit further, then ferric or iron is often a limiting nutrient for phytoplankton, and so eutrophication trials have been done, on adding ferric to the water to create algae blooms, which has been terribly successful. The first time that was done, I believe, was in Loch Fyne in Scotland during the Second World War to try and boost the herring and the haddock fishery. But I think all they ended up doing is killing everything with a plankton bloom. So, I think calcium carbonate or adding alkalinity to the water, I think the numbers are so horribly massive that that would be an extremely difficult and impractical thing to do. I think the best option is still to try and get to why is it happening? What is the root cause? And the root cause is most likely to be pollution from toxic chemicals and plastic. And if we just try and eliminate that pollution, then nature itself will bounce back really very quickly. And we've already seen that. We've been monitoring several environments around the world as a consequence of reduced tourism because of COVID. And it has been remarkable that many ecosystems are bouncing back really very fast. Coral reefs are recovering. Fish are coming back into coastal communities. Water is changing color. So, I think COVID has actually brought that one benefit that we have seen what can happen by reducing pollution in certain areas. So I think that's probably still the best approach to dealing with this problem.
Thank you. Yeah, thanks. I have noticed over the years that the echinoderms on the west coast of Ireland in tidal pools, where these wonderful tidal pools that you can bathe in, but they had purple sea urchins there when I went there first about 30, 40 years ago, and they've steadily disappeared over the years. And I suspected it was due to change in pH in the water. Thank you, Howard. Very good. Excellent. Well done.
You're welcome.
Howard, fantastic talk. You must be exhausted. It's rare that we go on for 2 hours, but the questions were great. And you obviously touched a chord. And I see Martin, he's posted disappeared, but Martin and Stephanie Fuller on Sandpiper are keen to sign up to your plankton sampling. They're sailing across the North Atlantic later on this year. But fantastic talk. Thank you very, very much indeed. And anything that the OCC can do to assist, promote, spread the message, lobby, then please steer us. We need advice as to what we can do, because we are global, and I guess we've got 3,500 members or 3,300 members in lots of different countries. So point us in the right direction, and we'll do what we can.
Great, that would be wonderful to work with you.
Great, thank you, Howard, and have a good trip back to Lagos. And I hope you get sailing and get across the Atlantic later on this year.
Well, I hope so. I absolutely hope so. So I'm just waiting for the COVID restrictions to lift and get the last injection, and then we'll be off.
Great, excellent. And thank you too, Diane. I see you've put some YouTube references and stuff on the Q&A. I hope people got those. Howard and Diane, I'll send you copies of the Q&A and the panelists, the chat lines and this will go up overnight as a recording. There's a question from Gary about sharing the slides. Are you happy with that, Howard, or are those downloadable from the Go site?
No problem. I can transfer the PowerPoint presentation to you if you wish. I can do that.
Well, I would just finish off, Simon. Just, you know, I know lots of the of other OCC members, and I have learned so much from them about ideas on boats and people using, we've got plastic on our boats, but it's not one use, and people reuse things. And I think it would just be great. I mean, I look at all these kind of things like plastic-free living and all of this kind of stuff. You know, and I make my own non-toxic cleaning products, which is basically bicarbonate of soda, and sometimes I'll add a wee bit of lemon juice, and make my own soaps and things, and they're far better most of the time than some of the bought products that you know, you go and you spend a small fortune on in the shambles. Bacteria and mold and all that kind of stuff on the boats. And as I say, a lot of that I've learned from other people on boats and people who've been living aboard. So I think there's a huge resource just within the membership, and having some kind of platform to share those ideas, but equally to have ongoing debates. I mean, you know, I can't remember the lady's name, but you know, she was talking about other coccolithophores, and you know, it's just such an interesting area, you know, just and bringing the life in the ocean. The number of people that I know that we know, and again, just chatting about that insurance guy today, he had never even heard of a plankton, and he is a mad keen surfer, and had never considered that there could be 17 million ton, or sorry, a mass of 17 million jumbo jets in the oceans, and that just blew him away. And he just said, how do we not know this? How do we not know that there's that number of plants in the oceans? We just don't think of these as plants. So it was a real wake-up call. And I think just being able to have a platform, or be able to share, or to have a debate, or it would be great to have, you know, there's lots of clever people in the OCC, and you know, to get other marine biologists and have, you know, I don't know, round the fireside with Simon, which we've all enjoyed over the winter.
Obviously the fire's gone out because it's been warm today. It's the whole series has been great, anyway, and so diverse, but
fantastic membership, and just so many helpful, interesting, and people ready to share their ideas and their learning, and you know, and to debate things. You know, everybody doesn't have to agree with things, but equally just seeing things from everybody's perspective and learning from experiences is just so hugely valuable for me, apart from anything else. So.
Sure, yeah. It's I guess our difficulty is reaching the whole membership, because obviously we get a couple of 100, 250, 300 people max on the webinars, but we're 3,500. Facebook goes to a few hundred, 500 perhaps maximum reach. It's working out what actually does get to everybody, and of course a lot of the OCC members probably aren't actively sailing. But
my other comment would have been about, you know, Oliver some of the sunscreens are expensive. He's right, and it depends where you look sometimes. But we know these manufacturers, and there's no reason why we couldn't. There is one of them in the UK. Badger's a US one, and it's considered to be one of the best. But as I say, we do know the UK manufacturer, but there's no reason why OCC couldn't even, you know, approach them and see if we could get a deal set up for OCC members.
Yeah, just thinking laterally, and you're obviously Edinburgh-based. A very good friend of mine is a bit of a suntan lotion entrepreneur there. He's a dermatologist who's put a filter in there to take the bad UVB out. So you get the vitamin D manufacturing benefits of sunlight without the skin cancer element. Do you know what he's using? Richard Fuller. He's an academic dermatologist in Edinburgh.
Yeah, and in fact, I met one of the top. I'm trying to remember his name just now. He was the top dermatologist in Scotland, and he was saying that skin cancers have increased by 100%, and a lot of it is because of the Spanish holiday, but it's also because a lot of the sort of toxic chemicals in makeups that, you know, youngsters are coming in on a Friday or Saturday night, having gone out, you know, to a disco, and this is obviously a year ago, and coming in with, you know, their eyes swollen or whatever, and there's stuff in it. But I'm just trying to remember his name. I'll find it and I'll send the name over. But I think there's going to be a lot of people are now looking at the innovation. And I think one of the things that we've also learned about with the work that Craig Downs is a forensic chemist, and he was working for the Spanish government, and they were at a stage where they were going to advise new mothers not to feed their baby, not to breastfeed, because unless they had taken direct action to remove the use of cosmetics before, you know, while they were pregnant, because they were, you know, the mammals, and this includes dolphins and whales, they will get rid of toxicity or toxic chemicals through breast milk or through other organs, or transfer it into the placenta. And I think, Howard, it's always the eldest or the first child or the first calf or whatever is born that will tend to get the bulk of all the chemicals from the parent. Or so there was that discussion in Spain, and I think Craig Downs has done all the toxicology work there, and again all the work in Martinique on the, you know, you shouldn't really eat anything other than a banana in Martinique because of all the use of ketone, which is another really, really nasty I suppose it was really used as I guess to keep the bugs down and keep them off the banana plants. So there's just so many things that are out there but there are a few, and I think that's really why we focused on the ones that are featured in the video, because these are so pervasive, and there are alternatives out there if people want. But we didn't really want to market to people. We don't want to sell people lots of cosmetics and stuff. That's our job.
Yeah, that's
but
right.
you can go and Google it. So yeah, so I think if we can share, or if there's a platform or whatever that might work for people, then, you know, it would be great. Or a fireside debate, and get 4 people on to put different points of view across. So anyway, it was really good actually to hear Howard going through this, because I haven't heard his presentation for
what? Look, we better wrap up, but what a great evening, and thank you very much. Very thought-provoking.
And we'll hopefully we'll see you up in on the West Coast at some stage soon too.
Yeah, well, we're going to be up there in the next couple of weeks in May. So I know you're heading off to Portugal, but if you are going up that way, then please drop by.
Awesome. Thank you.
All right. Bye, Dan. And bye-bye, Howard. And everybody else who's still online. Congratulations. It's been a marathon. Thank you very much. Good night.
Good night.